Okay, so let's start with the man in the middle without warnings through invalid SSL certificates. So basically for this attack, the only things that are required by an attacker are man in the middle. So for example, on public Wi-Fi without guest isolation. So some airport, some cafe or some other place like that, given there's 8 million people or 8 million downloads for the LeaveHomeSafe application, it seems quite likely that at least some users will be on some public Wi-Fi without guest isolation, or otherwise some other Wi-Fi where they can be attacked in this way. Right, and then this was tested on an Android 6 device. It worked on both a physical Google Nexus 5, for which the last update available is Android 6.0.1. It may also work in other Android versions. We didn't have time to test all the versions, but what matters is that in at least some of the Android versions supported by the application, this attack is possible, right? So the iOS application is not affected by this issue. This is a flaw in the Android, in the LeaveHomeSafe Android application only. And the impact is quite high, right? So because the attacker, in this case, can provide an invalid certificate, which will allow to intercept the traffic between the LeaveHomeSafe Android application and the LeaveHomeSafe servers. So when the user tries to log into the Hong Kong health code system, then the attacker can man in the middle that traffic and gain access to the Hong Kong identity card and other data from the user, right? So the Hong Kong identity card, the password of the user, as well as the one-time password, right? So this is also a two-factor authentication bypass. So you would basically gain full access to the Hong Kong health code system on behalf of the user. And then once you have access to that on the server, you can access whatever it is that you can do on the Hong Kong health code system, right? So how does this attack work? Um, we need two attack requirements. One is the attacker has man in the middle on some public Wi-Fi without guest isolation, for example. And the second requirement is that the attacker needs some certificate that has been signed by a certification authority that is going to be trusted by the device. So for this, you only need to have any domain on the internet, and then you can get this SSL certificate for free, for example, from Let's Encrypt, which is going to be free, right? And then what you do is using Burp, for example, on the certificate tab, you can set generate a CA sign certificate, so a certificate that will be trusted by the device with a specific host name, right? So we provide a hostname of 7asecurity.com for testing purposes. So what this is going to do, it is going to always show a certificate that is going to be valid, but only valid for 7asecurity.com, right? So with this certificate, you should not be able to man in the middle the LeaveHomeSafe servers or Facebook or Google or any other server host on the internet, because the certificate is only valid for 7asecurity.com and not any other server, right? So that is what this attack is about, is when you provide a CA sign certificate, but for a wrong hostname, right? So the problem is in the hostname verification part of SSL validation. So let's see how this works, right? So first, we need to show how the Android browser shows security warnings. So first, let me just show you how normal SSL works. So if I go here to the Android browser, you can see that I'm on Google, there's no warnings, I can search 7asecurity, whatever, and here I can see that the traffic is being captured, right? So I can search for 7asecurity, for example, and then this traffic will be intercepted in Burp, right? So you can see there's the search going on and so on, and there were no security warnings, right? Now, if I go here and I change this, and now I'm going to say that the certificate is going to be a CA sign certificate with a specific host name of 7asecurity.com, right? So I hit OK on this. Now from now on, Burp is going to send a CA sign certificate, so a certificate, for example, signed with Let's Encrypt, right? So some certification authority trusted by the device, but it's going to be a valid certificate only for this host and no other host on the internet, right? So only this host. So if I hit OK on this, Now I will not be able to man in the middle Google anymore. So if I repeat this search, now there should be some warning by the browser. It should say that there's some problems with the security certificate for this site because I'm on google.com, right, or google.ie, the Irish version, and you can see that this is not working anymore, right? So we can no longer intercept traffic. Similarly, if you go to the report and you just try this command, so I'm just going to copy this, and then you can see that I already installed the latest LeaveHomeSafe application 3.3.0 released on June 2nd, 2022, which is still the latest as of June 29th. So now if I send this to the Android browser, this is going to send the LeaveHomeSafe website to the browser, and the browser should complain that the certificate is invalid, right? So you can see that the URL changed to LeaveHomeSafe. However, there's a security warning, right? So now let's see what LeaveHomeSafe does, right? So if I now go here and find LeaveHomeSafe somewhere, so let me see if I can find it. So this is LeaveHomeSafe. So I'm just going to open it. And then I'm just going to go here to the HTTP history, and you can see that we already have some traffic from the application. So I'm just going to delete these items. So you can see that the application is making SSL requests to the backend, right? So LeaveHomeSafe, site.json, this other Hong Kong government website, and so on. Here on the phone, we don't have any warnings, right? So do you see any warnings alerting the user of this? No, we can intercept all traffic without warnings, even though the browser complains, right, that the certificate is invalid. So the certificate is not being valid, is not being tested correctly, right? So for validation. So now I'm going to just skip all this. And I'm just going to hit next and start. Okay, so this finished loading. And now if you navigate to the right of the LeaveHomeSafe application, there is this Hong Kong health code system, right? So this is the place where you can log in to the Hong Kong health code system. So I can hit agree on this. And then there's a few options, Hong Kong health code system. So you can see there's some warnings on the browser itself. But if we go back to the application, I can go here to upload visit records to Hong Kong Health Code. And here we have a login screen, right? So this is the login to the Hong Kong Health Code system. So in the browser, we have warnings, but in the application, we don't, right? So if I use some Hong Kong identity card number, let me just go back to the report and get a valid one. Right, so you can see the SSL certificate warnings from the Android browser. However, if we navigate to the Hong Kong Health Code system login, we try this Hong Kong identity card number, which is a fake one, just used by one generator. So it's A123456, and then the control digit is 3. So 123456. So I'm just going to try this. And you can see in Burp, we are intercepting the LeaveHomeSafe traffic all the time. So this could also be spoofed by an attacker. So this is the Hong Kong Health Code System credentials. So 123456. Now I'm going to put here the digit. And here I'm just going to put here like my secret password and some exclamation points. I'm going to also remember the login information. This doesn't really matter. You can disable it if you want to. Now I'm just going to show again burp. And if I hit login on this, you can see that this is loading. And this is sending the credentials, right? So a request is made to the logging endpoint. These are the credentials, the Hong Kong username, the secret password, right? So you can see the username and the secret password. So the credentials could be captured by an attacker. Of course, the login information is incorrect, but this demonstrates that user credentials could be captured without any warnings, right? So the application hasn't shown any warnings. And the question is why, right? So if we look at the decompiled application, and you can try this on your own, right? You can download LeaveHomeSafe from Google Play and decompile the application and do the same thing, right? So if I go here and you do a global search on the decompiled APK for hostname verifier, right? So you do a grep, ignore the binary files, and would you search for global hostname verifier? Now I hit enter on this. This is going to show this is going to show some results, right? So I'm just going to this grep is removing some libraries like OKHTTP and ORMFetch, because these are libraries, and this is the actual code of the application, right, by this vendor. So what we can do is just pass this to VI, right? So I can VI of cat F1D. So basically, I'm just going to open this file, Java source, government, Hong Kong government, and so on. So if I edit this, you can see that this is the hostname verifier code, right? So there's this verify method, and then what it's doing is if the server contains these government, Hong Kong government websites, right, all the validation is going to be true, right? So in English, what this is doing is if the server I am connecting to, right, this is the logic of the LeaveHomeSafe Android application. If the server I am connecting to is this sensitive server where users log in and are going to send their credentials to, if it is that server, then skip all validation, right? So verify is just returning true, right? So this is what is allowing an attacker with man-in-the-middle capabilities, for example, on Open Wi-Fi, to capture the user credentials, right? So we have the Hong Kong ID and the Hong Kong password, right? So this is my secret password. And if I go to the report, another possibility could also be like other screens, like if you try to upload your COVID information, right? So, so if I go, because there's other screens as well, like to upload electronic vaccination and testing record and other stuff like this. So you could also do this on other screens, and when you upload your information, this is also being intercepted, right? So there's this one, and then there is the report positive or preliminary positive, right? So this is the screen that is being shown on the report. So when you report that you are positive for COVID, so if I navigate to burp and scroll all the way down, and now here I'm going to put, like, this is my case number, so I'm just going to put some numbers here. I'm John Smith, and this is my contact number. And then I just hit that I have read and so on, and then I agree. And then this is the second factor authentication, right? So this verification code, if I enter it here, right? So this would be what the user receives on the phone. So if I enter here some numbers and I agree to upload visit records, so if I agree on upload visit records now, the attacker is going to receive the second factor authentication, as well as the information for the case code and so on, right? So this is the case number, this is the verification code, and then we could spoof the reply and say that the code is valid, so the application keeps sending more information, right? But what matters is that we can intercept valid two-factor tokens from users without any user warnings. You could see there was no SSL warning here, the same way that we have a security warning if we open the Android browser in this state, right? So if I go here and I open the LeaveHomeSafe domain on the Android browser, in this setup you can see the security warnings, whereas on the LeaveHomeSafe application itself, there were no warnings at all. Right, so with this, I hope the man-in-the-middle vulnerability is perfectly clear. With this live demo using LeaveHomeSafe 3.3.0, which is the latest at the time of recording on July 29th, 2022.